Hi students, this is Subhanil sir, and today we will discuss one of the toughest questions that has come in JEE Advanced, and this question was given in JEE 2016. So before we jump into the solution, you need to know few theories regarding the problem. The first concept that you need to know is what is displacement. Displacement is the coordinate. So suppose if this is a coordinate axis system, this is the x-axis and y-axis, and suppose here is a point A. So if I join the origin with the point A, this OA bar that I get is the displacement. Now OA bar, the point A has coordinate x comma y. So what is the displacement along x-axis? It is x, and the displacement along y-axis is y. So OA bar is basically xi cap plus yj cap. Now let me take the magnitude of this OA bar as r, and this angle is theta. So what will be this OA bar? Let me call it r bar. So r bar is going to be r into cos theta I cap plus sin theta j cap. Now what are the possibilities between r and theta? So the first possibility is that r is constant and theta is varying. In that case, the motion is going to be circular because the distance from the center remains always fixed and the particle is rotating, right? Another possibility is that theta is constant. This angle theta is constant and the r is varying. In that case, what is the motion? That is going to be translational motion. Now there is another possibility, and that possibility is that both r and theta are varying. So in that case, your velocity vector is going to be rate of change of displacement, which is the r bar dr dt. But remember, in this case, both r and theta are variable. So how will you get this r and theta? Now let me zoom into this figure. So you can easily see that if r and theta both are variable, you have to take the derivative of this equation in the u into v form. And what will be the answer of that? It is going to be cos theta I cap plus sin theta j cap into dr dt, right? Theta being constant and r is varying. And in the second case, r is constant and theta is varying. So if I take the derivative of this, I get minus sin theta I cap plus cos theta j cap into d theta dt. But d theta dt is omega, right? Now let me zoom into this figure and let me extend this line. So r is varying and theta is also changing. So it is basically a curved motion where both r and theta are varying. So if this is your r bar, what will be r cap? The r cap is going to be r bar divided by r. So that is going to be cos theta I cap plus sin theta j cap. So this part, see, cos theta I cap plus sin theta j cap, this is basically what? This is the r cap. So velocity vector, what I am getting dr dt, which is the derivative of r into r cap plus r, this r, and d theta dt is the omega, r into omega, multiplied with this first bracket term minus sin theta I cap plus cos theta j cap. Now what is this term? So if you can see, if I draw a horizontal here, this angle is theta, so this is going to be also theta. Now draw a perpendicular. So this is the perpendicular. If this is your theta, then this angle is going to be how much? 90 minus theta. And what will be the direction of the change of theta? So use the right hand thumb rule. You put the wrist of your right hand at the origin O and curl your palm in the direction of theta. So if you do that, you get the direction of the theta changing, right? So that's going to be this direction, which is the tangent direction. Am I clear? So this white line with the blue line, the extended red, which is drawn in the blue color, that white and blue makes how much angle? 90 degree, because that's the radial line and this is the tangent line. Now this angle is going to be 90 minus theta. This means this angle is theta. Okay. So if this white color is the direction of what? It is the direction of theta changing. So this means I can say that this white color line, the vector, is the direction of theta cap because theta is in that direction. I hope you are getting the point. So what will be theta cap? So see, from simple vector component, I can easily see that it is going to be minus sin theta I cap plus cos theta j cap, right? So if you see this term, now see this term minus sin theta I cap plus cos theta j cap is basically theta cap. So you got the velocity. So this is the velocity formula. So it is what? If both radius and theta are varying, which happens in case of a curved motion, the formula is r dot, that means dr dt, into r cap plus r omega into theta cap. Theta cap is the direction of change of theta. Now, if you take the derivative of this acceleration vector and take the derivative in the u and v form, remember both r dot, r cap and theta cap including omega, everything is variable here. So if you take the derivative of this, you will get this formula 2r dot theta dot plus r theta double dot, that means r alpha. Okay, these are theta double dot into theta cap plus r double dot minus omega square r into r cap. So this is a formula that you have to memorize. This is the acceleration of a particle in a curved motion where both position vector length and the angle are varying. So this you won't get in the class 11-12 book. So this is a formula that is very important for JEE Mains and JEE Advanced level question. Now this factor is called Coriolis effect. Okay, and this is the radial acceleration. So if you have understood this part, this derivative I am giving you as a homework. You just take the derivative of this velocity that I have solved for you and you will come into this formula, and remember this formula. The derivation is obviously important, but even if you cannot derive or suppose you don't have the time for it, at least memorize this formula. Okay. Now using this, how can we solve the iconic JEE Advanced 2016 question? Let us jump into that solution. So first you see the question. The question is, I'll just share the question. This is the question. See. So there are a lot of it's a paragraph based question, and there are a lot of things that are being told in this question. So if you go through this question, it gives you that vibe that no, I'll skip the question, right? But you can solve it. So from where you have to start is that from here, and just follow the theory that I did for you. So see, we assign a coordinate system with the origin at the center. So this is the origin here. This point is the origin. Okay. The x-axis along the slot. So this is the slot. So this is a disc, there is a groove, and there is a mass small m which is kept very gently on that groove. And the disc is rotating with uniform angular velocity omega. From right hand thumb rule, you can easily understand the direction of this omega is along z axis, which is given here. Omega bar is equal to omega k cap. Okay. Now a block of mass small m. So this block has mass small m. It is kept. This block of mass small m is kept very gently on that slot, and this slot is also smooth, so there is no friction there. Now because there is no friction there, that means there is no unbalanced force in the radial direction. That means from Newton's second law, the unbalanced force formula is what? Mass into acceleration. Now the theory that we did, what is the acceleration of a particle or a block in the direction of radius? The formula is r double dot minus omega square r, right? This is the acceleration. But because there is no real force along that line, there is no friction there, because other than friction, there cannot be any real force acting on the disk along the radius. This means this acceleration A, whose value is m into r double dot, is a radial acceleration. Okay, I'll give a r representing radial acceleration. So m into r double dot minus omega square r must be equal to how much? It must be equal to 0. So the solution that I'm getting is r double dot is equal to omega square r. So this is the condition for which this block is kept. Now what we have to find out? We have to find out this distance r. Now from mathematics, suppose if you have a derivative, like I'll just explain to you this thing. Suppose you have r double dot is equal to omega square r. In this case, the solution of r is equal to a e to the power omega t plus b e to the power minus omega t. This you have to memorize. To explain, suppose if I assume this value, r is equal to a e to the power omega t plus b e to the power minus omega t. Suppose this is what I assumed. Let this is be the r. So take a derivative of this. So dr dt. That means r single dot, right? That's it. Dr dt. What will be the answer of this? A omega e to the power omega t minus b omega e to the power minus omega t. Now take again derivative. That means r double dot. So that is d2r dt2. In this case, what you will get? A, and here you will get omega. So omega square e to the power omega t. Now minus b omega, and here is a minus sign, minus omega. So it will come out and it will make it plus b omega square e to the power minus omega t. Take omega square out. So if you take omega square out, you are left with a e to the power omega t plus b e to the power minus omega t. But this first bracket term is our assumption of r, right? So what we got, r double dot is equal to omega square r. So this is something that you have to know from maths. So I just derived for you. So please do remember, if r double dot is equal to omega square r, then what is the value of r? It is the value of r. Okay. So now for this particular problem, you can easily see, because the distance r of the block at the time t is obeying this condition, r double dot is equal to omega square r. That means what can I write about r? I can write about r as r is equal to a e to the power omega t plus b e to the power minus omega t. It must follow this equation. Now the problem is that I have no idea what are the values of a and b. So I have to solve for a and b. Now see, it is given that at t equal to 0, at this value t equal to 0, where it is kept? It is kept at r bar equal to r by 2 I cap. That means mod value is how much? R by 2. So put small r equal to r by 2. So I put r by 2. Put t equal to 0. So what I have got? I have got a e to the power omega into 0. That means e to the power 0, it becomes 1. E to the power minus 0 also becomes 1. So a plus b is equal to r by 2. This is the first equation that I have got. Now the problem is that there are two unknowns, a and b, and I have got only one equation, a plus b is equal to r by 2. So I cannot solve, right? So to solve, I need another equation. So for that, what I will see is that here this word is gently placed on the slot. This word gently placed on the slot. That means along that groove, along that slot, there is no velocity because the disk is rotating, right? So everything is having what? Tangential velocity. No velocity in that radially outward direction, not inward direction. This means that dr dt at t equal to 0 must be what? 0. So we'll take the derivative of this. So we'll take dr dt. So dr dt will give me the radial velocity. So dr dt will be how much? That's going to be a omega e to the power omega t minus b omega e to the power minus omega t. Now put t equal to 0. So if I put t equal to 0, your v becomes how much? 0 along the radial line. So this becomes a omega minus b omega is equal to 0. So if I do the side change, omega cancels out. This becomes a equal to b. But a plus b is how much? A plus b is equal to r by 2 and a is equal to b. This means the value of a equal to b is equal to how much? It becomes r by 4. So this means that equation of small r, which is the distance from the center of this particular disk, that small r becomes how much? Small r becomes r by 4 common e to the power omega t plus e to the power minus omega t. This is the small r of the block, which is the distance from the center. Small r is equal to this value, which is in the, if you check the option, which is option A. So we solve this first part. Now, let us come to the second part. The second part is asking the net reaction of the disk on the block. Now, visualize this disk is there. This disk is kept on this xy plane. This is the x-axis. This is the y-axis and the top is the z-axis. So this means from the center of mass, gravity mg will act in what direction? Vertically downward, that means along negative z-axis. So the disk's molecule interacts with the surface molecule of the block's molecule interacts with the surface molecule of the disk. That means there will be a normal reaction in the vertically upward direction. So the first normal reaction N1 bar is going to be how much? N1 K cap, and N1 value must be equal to mg. So mg K cap. So this will be a part of the reaction. So just check in the option where this mg K cap is there. It is in the option A as well as in option B, but not there in C and D. That means the answer must be between A and B. Now how to get the other part, because there has to be some other reaction force. Now remember that when we are deriving this theory, when we are I was asking you to memorize this acceleration. See, along the tangent there is this acceleration 2 r dot theta dot plus r alpha, or you can say alpha as the theta double dot, right? This is alpha, double derivative of theta. So as the disk according to the problem is having omega constant, right? It is rotating with the constant omega. Here, constant angular speed. So this means your d omega dt or theta double dot must be equal to how much? 0, right? So the acceleration in this theta cap direction, I can write it as a theta will be how much? It is going to be a theta will be 2 r dot theta dot, because alpha becomes 0. Now theta dot is omega, so 2 r dot into omega, that is the net acceleration along the tangent by that formula. Now your r is how much? R is given by this formula. That is what we have solved. The r is here, this one, this is the r. So the acceleration in the direction of tangent a theta will be how much? R by 4 constant, derivative of this will give me omega out, so that this will be how much? This will be r by 4 omega out e to the power omega t minus e to the power minus omega t, right? This is the r dot. So 2 into r dot into omega. So the acceleration value, the net acceleration along that tangent will be r by 2 omega square, omega here and omega here. So that gives me omega square into e to the power omega t minus e to the power minus omega t. Now multiply this with the mass m. So this is going to give me the normal reaction provided by the walls of that groove. This means this part, the walls here, this part one wall and here another wall. The net unbalanced force provided by those walls is in this direction, in the direction of the theta, a theta. So this is one normal reaction, right? One reaction. And what is the direction of this normal reaction? You can easily see this vector is parallel to which one? This is the direction of n theta, which is in the direction of a theta. And that n theta is in the direction of y. So n theta bar vector will be what? This vector is going to be multiplied with j cap. So the answer is this value plus mg k cap. Where you have got, do you have this answer? M r square by 2 e to the power omega t minus e to the power minus omega t j cap. You can check this plus mg k cap. So the answer is option B. So I hope you really like this solution, and if you have liked this solution, please give it a thumbs up. Do subscribe to my channel. I'll bring more such videos, and I really hope that you have really liked this video. Thank you for watching. Tata. See you in the next video.